This chapter deals with the different rules about taking the derivative. First rule, theorem 3.2, is the constant rule. So if you take the derivative of a constant, it's zero, because remember, that's the slope of the tangent line. So if you've got a graph, it looks, say this is f of x. Say f of x equals, say, 2. So that's 2 up, whatever. Any point that you take on that line, finding the slope at that line is going to be 0. So the line x equals, the slope is always 0, so it doesn't matter what point you take, it's always going to be 0. So f prime of x will equal 0. Or, again, they've got this notation d dx. This simply means the derivative with respect to x. Sometimes you'll see dy dx, so the derivative of the function y instead of f of x. All right, so the more useful of these two theorems is the power rule. So if you're in a situation where n is a positive integer, and actually this works for any integer or any rational number, the proof that they give uses just the positive integers, but again, this will be useful for anything, and I'll explain with the number 0 in a moment. Then we can take the derivative f prime of x. We take the exponent, move it in front, and multiply it by whatever the coefficient is. In this case, it's 1. And then we also subtract 1 from whatever it was. So an example, say f of x equals x cubed. And f prime of x equals 3x squared. 3 comes down, and 3 minus 1 is 2. Another example, 2x to the 4th. So y equals that. So y prime is another way to write this. Y with the superscript dash. That's 4 times 2x to the 4 minus 1, which equals 8x cubed.